In today's video, we're going to be looking at a problem where we need to calculate our coefficients and then a residual. So to start off, what is a residual? A residual is just the observed minus expected. So this is normally, I just have this memorized, but if you don't remember if it's observed minus expected or expected minus observed, you can think back to the fact that the observed y is equivalent to your prediction plus some error term, right? That error term is the residual. So this is the exact same equation, just flipped around. So we can just, to solve for epsilon, subtract y half from both sides, and that's how we get our observed minus expected. So if we scroll back up to the problem, we need to calculate the residual, and the answers include both positive and negative answers. So you got to make sure you get the direction correct here. Next, we need to calculate our coefficients in order to be able to calculate our predictions to then calculate the residuals. If you want to do this by hand, I have these equations written out here. And maybe we could derive that in a future video if enough people are interested in that. But for this problem, I figured we'd just use the calculator. So for that, let me pull up the calculator and the data. So what you want to do is go to data and then just input this information. So the columns don't matter which one you put them in, but you reference them later. So you'll see this says L1, L2, and L3. So I'll just put X or advertising in L1 and sales or my Y variable in L2. Input the data, hit enter, and it goes down one. Now that I've finished a column, I'm going to go to the right, and it jumps up to the top. Now that I've finished inputting my data, I could say second quit, do some random math. The data is still going to be there, as you can see. And now what I want to do is calculate the statistics of interest. So what we're going to do is hit second. So that means we're going to be corresponding to the green words and go to stat. So green data is stat. And then 1 var versus 2 var. So if all you're interested in is calculating the sample mean and sample standard deviation of one variable, you'd go to 1 var, but we want to do 2 var because we're interested in fitting a regression. And here's where you select which columns you want. So we could have extra data in L3 and that wouldn't cause any issues so long as we don't select it. So again, we put our X variable advertising in L1, Y and L2. So those are fine. Then enter. And now if we scroll through here, we'll see a bunch of data. So the sample size, we have X bar, the sample and population, standard deviation, and a few other things for X and Y. And if you scroll all the way down, eventually you get to A and B. So here we have A and B, and that is of the form our linear regression is going to be y hat equals ax plus b, where A is the slope. So for each 1 unit of increase in x, our prediction is going to increase by 23. And then B, which is our intercept. So if x equals 0, our prediction would be negative 29. So with those values, we plug that in, along with the fact that x for the third observation, because we're interested in getting at the residual for the third observation, that x value is 6, and the y value is 112. So y equals ax plus b gets us a prediction of 113.66. And then we know our residual is our observed minus expected. So we observed 112, we expected or our model predicted 113.66. That's how we get our prediction of negative 1.66. Scrolling up, we see that corresponds to B. So that's our final answer. As always, thanks for watching.